Okay, let's continue our discussion of matrices by looking at this idea of inverting. So, before we get into inverting a matrix, we need to understand what is meant by something called the identity. And the identity matrix is simply any matrix that has a diagonal, specifically top left to bottom right, of ones and everything else being full of zeros. This is an identity matrix. This is also an identity matrix. This is not an identity matrix. We have to have a clean line of ones going from the top left to the bottom right with only zeros everywhere else. So if we have that, no matter how big the matrix, we have an identity. Now, why is the identity matrix useful? Well, a number of reasons. It's essentially just a very simple basic matrix that we can pull out into a lot of algebra. And when we're considering this idea of inverting a matrix, what we mean by that is almost a matrix that cancels itself out, right? A plus cancels a minus, times cancels a divide, etc. So in order to cancel a matrix, we need to invert it. So let's say I have a matrix M. The inverse of that matrix is m to the minus 1. Okay, our standard form for an inversion is to the minus 1. And what this essentially means is that if the matrix M is multiplied by its inverse, first things first, this is commutative, meaning it is the same both ways. And secondly, what it means is it is equal to an identity. So we know if we have inverted a matrix because if we multiply a matrix by its inverted self, either way round, it gives us the identity. So, for example, before I show you how to make or how to find an inverted matrix, if we come up with the matrix 3, 2, 2, 1, and I will tell you now, and I'll prove it in a second, that the inverse of this is minus 1, 2, 2, minus 3. We'll see why in a second. If I multiply these two together, let's do it. We should have 3 times minus 1, which is minus 3, plus 2 times 2, which is 4. And in the top right, we will have 3 times 2, which is 6, plus 2 times minus 3, which is minus 6. Bottom, we will have 2 times minus 1 is minus 2, plus 2. And in the bottom right, we will have 2 times 2 is 4, plus 1 times minus 3, which is minus 3. And as you see, we end up with 1, 0, 0, 1, which is the identity. So this is our goal. This is our goal of inverting a matrix. So how exactly do we invert a 2 by 2 matrix? So let's use that example I just did of 3, 2, 2, 1, and I want to prove the inverse of this. Now, it is a little bit tricky to remember sometimes, but there is a nice formula. First of all, we need to remember from the last video what the determinant is. So if you need a reminder, go back to my last video where we spoke about how to calculate a determinant, but we're going to need it. Because what we want is to find the determinant and reciprocate it. So if this is my matrix M, I'm going to take 1 divided by the determinant of my matrix. And I'm going to multiply that, and this is where it gets a bit weird to remember. My top right and bottom left values are going to be made negative. Okay? So if this was simply A, B, C, D, the matrix, then I'm going to end up with a minus B and a minus C. Then I'm going to swap the places of A and D, of the top left and the bottom right. So my top left becomes 1 or D. I'll just keep using letters for now. And the bottom right becomes A. And this seems pretty counterintuitive. It does seem a bit weird, but you will soon see why this is the case. And y, when we flip all this and multiply it by 1 divided by the determinant, we get our inverse. So let's apply this to this matrix. So I'm going to end up with, and I'm just going to reuse this area here, 1 divided by the determinant, we'll worry about that in a minute, times by, well, my 2 and my 2 become negative, so I have a -2 there and a -2 there, and my 1 and my 3 swap. So instead of having a 3 in the top left, I'll have a 1. Instead of having a 1 in the bottom right, I will have a 3. Now I need to find my determinants. So if we remember, the determinant of a 2 by 2 matrix is A times D, so 3 times 1, minus 2 times 2, which is 3 minus 4, which is -1. So if I pop all this into my formula, my determinant is -1. 1 divided by -1 is just -1. And I end up with the fact that my inverted matrix simply becomes this thing times -1, which is -1, 2, 2, 3, which is the same thing that I got earlier, and I've already proven that the original matrix times by this gets you the identity. So this is how you invert a 2 by 2 matrix.